previously 12 students, all they just did was write it down once, what I'm maybe writing now, and then just stuck it on their wall, and that stayed until the end of their HSC. So, you know, eventually it'll go in. So just give it some time, but it's got to be memorized. Okay, so the first thing is our expansions of trig plus minus, that becomes sine A cos B plus minus cos A sine B. If it's cos, if it's plus and minus, or if it's plus, that means it's going to be cos cos, but then minus, and then plus sine A sine B. Tan A plus minus B, tan A plus minus tan B on 1 minus plus tan A tan B. Any questions about these three? Erin?
No.
Okay, then from there we would have learned our double angles or double angle results from this. So if A was and B were both the same letter, so and you're going to add them, so A plus A, you would end up with like sine 2A or sine 2 theta. That becomes sine theta plus sine theta cos theta, and let's say cos theta sine theta. So essentially they become the same, which means sine 2 theta will result in becoming 2 sine theta cos theta. Same thing for cos. That becomes cos cos, which is cos squared, and then minus sine squared. But because you know a relationship in sine squared back in 2 unit, you can change sine squared to 1 minus cos squared, and you should end up with this. Or you can change cos squared to 1 minus sine squared, and you'll end up with this. And the way I memorize these two is just knowing if I've got to change this one, then this one becomes a 2 minus 1. If I've got to change this one becomes a 2, and then put a 1 at the front. So I guess I think of it from the original. Tan 2 theta, again tan plus tan, that becomes 2 tan on 1 minus tan times tan, tan squared theta. Any questions there?
No.
Then from that, this result, we get t equals tan theta on 2. So if I knew that t was tan theta on 2, that means technically, so if I'm halving the angle, technically this becomes tan theta, right? I'm going to halve the angle, and each one of these are going to halve as well. Are you okay with me writing that? Does that make sense? What I just did there? And that's when you end up with this result, which brings us to our t formula results. That's theta, tan theta is equal to opposite 2t on adjacent. And then using Pythagoras, you get this last side out. So it's good to know where it comes from, because a lot of people think it's just t formula, but reality is this guy and this guy are the same. See? 2t, 1 minus t squared, 2t, 1 minus t squared. So it's the same formula. It's just this is half the angle. Any questions now?
No.
So it looks like a lot, but they're linked. And you've got to just find that link. What's the last thing? Auxiliary angles. Okay. If you're trying to solve now, there are 2 methods. There is, for extension 1, there is the, the auxiliary or the R method. We'll just call that R and theta, but it's called the auxiliary, or that's what I call it. Or some books I know call it transformations. You can think of it like that, auxiliary. And the other second method would be T formula. Now there is a problem with T formula. You have to always check if, let's just say T, if theta equals 180 is a solution. You got to always check that so that it's not flawless when you're solving. This guy, however, is flawless. All you've got to do is find r and theta, where r is Pythagoras and theta is inverse tan. Remember, positive b and positive a. So if b was negative, you don't use it. You make it positive. And then the formula pretty much is this. If it was, let's say, a sine theta plus b cos theta, that gets transformed to r sine theta plus alpha. Oh, I should have made this alpha so you don't get confused. Yes? Again, yeah. Alpha is positive, positive. And if it's sine, it's sine. If it's cos, it's cos. That's the logic. So if it was a cos theta plus b sine theta, it's r cos, and then theta minus alpha. Excuse me. The reason why it's minus is the same logic up here. If it was a plus, it's a minus. So if it's a plus, it's a minus. Any questions?
No.
So let's do some questions now. I think that's it. It's pretty much all the formulas you need to know for extension trig. Now there's a lot, obviously. I know you're given a formula sheet. Don't depend on it. You got to know it. If you're able, think of it like this. If you're able to write everything I just wrote and teach it to me next week, week after, whatever, you know, regardless of the question, you know all your formulas.
Yeah.
So you're not going to stall. And that's what you're aiming for. I guess we'll do this one. Question 5 and maybe 6. Okay. 5a. Express 3 cos x minus 2 sin x in the form a cos x plus theta. Okay. A equals square root 3 squared plus 2 squared. 9 plus 4, root 13. Theta equals inverse tan of 2 over 3. Get my calculator back to degree mode. Inverse tan 2 over 3. I'm just going to round it up to 34 degrees. And then I'm done. So 3 cos x minus 2 sin x. I said if it starts with a cos, the general rule is it should be a cos here, and then an x. If it says a minus, that's a plus, and then 34 degrees. Even if this was a plus, just so you guys know, they'll still write plus here. Right? You're meant to know that theta is negative. So they don't need to tell you it's a negative here. That's just a generic formula. Just saying in that form.
Done auxiliary angles like this way, so I don't like get it.
Okay, that's fine. So what have you done then in extension trig?
Like we've done like auxiliary angles, but like we did it some like other way. Like we used the formula, but like we worked it out differently.
What? How did you do it then? How would you have done A?
I don't know.
Okay, strange. Azra, maybe Azra can tell us if she's done it differently as well. I don't know. Let's find out. Azra, different or same as mine? Let's find out. Same? All right, fair enough then. Then, Erin, let's learn it.
Yeah.
All right, so it's very easy though. If you know your formulas, like literally, if you know where R and alpha stand for, R is Pythagoras, so very easy. And then alpha is just your inverse tan of B on A. If you know those two formulas, then just watch how it's applied. So 3 squared plus 2 squared, a squared plus b squared. And then we're just square rooting it. And then the same thing here. Theta equals inverse tan b on a. B on a. B on a, which equals 34 degrees. And therefore you get this.
Oh, yeah, okay, that kind of makes sense.
Okay, we'll do more. But once we're done, the idea is we're going to, it says, hence solve this. Of course, you're not meant to use that. You're meant to go root 13 cos x plus 34 equals to 1. And then that brings us to the question that we did very early on with the whole adding and subtracting 3/6 and stuff and being careful of all our solutions. So let's finish this one off. Divide by root 13 and inverse cos is what I'm going to do at the same time. So inverse cos of 1 on root 13. And that gives me, well, it says to the nearest minute now. It's annoying because I've already rounded this one to 34 degrees. I'm just going to change the question. Make it nearest degree. Too bad. 74 degrees. Okay, and then all stations to central. Where is cos positive? Here and here. 360 minus 74. You're still with me?
Yeah.
286. And then because you know you're about to subtract 34, the question you've got to really think about is if I added 360 to this, which I'm going to do, right? It's 434. By the time you subtract 34, are you going to get within 360? And you're probably not. But it's safer to tell you to do it and then see that it doesn't, then hey, just miss it and do it like this until you get a question and then you realize you haven't got used to it and then you got to relearn everything and that's just a waste of time.
Yeah.
You get what I mean? So you might as well see that you can add 360. It's just that in this case, but if this was like 80 degrees, hey, that would get you within your region, wouldn't it?
Yeah.
So you got to watch out. But because it's only 34, by the time you subtract, this gives you 40, 286, take away 34, you're at 252. This one, you're too large, and you're done. Make sense? We'll do another one.
Yeah.
Let's do another one. Hold on. Were you copying down?
Yeah.
All right, give me a sec. I'll just get you a bunch of these. We'll just do the transformations. Is the solving okay?
Yeah, it's okay. It's quicker than like how we've done it before.
Usually
That's good.
the case. What was I saying? If the solving's okay, just to get at least through induction if you like, if the solving's okay, I can just show you what your first line's going to be. And you can try it out.
Yeah.
And then you can just take a photo of your solution, send it to me later, tonight or whatever, and I'll mark it for you.
Yeah.
Okay. Number 2. Let's try number 2. So again, the formula is square root of a squared plus b squared, and alpha is inverse tan b on a. So in this case, a is 1 and b is 1. So therefore, you just get square root of 2. And then alpha equals inverse tan of 1 on 1, which is 1. Pi on 4. Does that make sense?
Yeah.
And then since it's sine, it's sine. If it's minus for sine, it's still minus. So they've helped me out like that. That's great. But don't get used to that. They will trick you sometimes. So just be careful. You got to know it. Root 2 sine x minus pi on 4. You just transform that, sine and cos, to just sines.
Yeah.
And then, of course, you can see hence solve equals to root 2 So you're going to divide by the root 2, shift sign, and pretty much finish it off. Any questions?
No.
All right, we'll do one more. Well, I mean, we'll do 4. 4 makes sense, then 3 will make sense. 4. Again, you know I've got to find my r. A squared, so 2 squared plus root 5 squared. 5 plus 4 is 9. That gives me 3. Does that make sense?
Yeah.
And then alpha. Inverse tan B on A. And whatever that gives you. And then you're technically done. So inverse tan root 5 all over 2 is 48 degrees. And then the answer we want is 3 sine x plus, because that's a plus, and then alpha. And then eventually you want to solve it for 3. Any questions?
No.
You reckon you got used to this now? Or you will
Yeah.
you can get used to that? Yeah, pretty straightforward if you follow these formulas. Who's your teacher, Ferriccioli?
Yeah, I got a good Samaritan.
Sorry? Oh, good Samaritan. Who's your teacher?
Yeah.
Felipe?
Mr. Cherkop. No.
Mr.
Cherkop.
Chekhov. Oh, don't know him. No, don't know him. And Felipe. Have you had Mr. What's his last name?
Oyazin?
Oh yeah, Oyazin.
No, I didn't have him.
He's a really good teacher. All right. All good. That all makes sense. Then we'll leave that. Stop that.